A rough plane is inclined at an angle alpha to the horizontal, where sine alpha is 3/5. A body of mass 80 kilograms lies on the plane. The coefficient of friction between the body and the plane is mu. Find the normal reaction of the plane on the body. The body is on the point of slipping down the plane. Find the value of mu. Calculate the magnitude of the force acting along a line of greatest slope that will move the body up the plane with an acceleration of 0.7 meters per second. So I've got the question in summary form here with all the information. Sine alpha is 3/5, so the opposite over the hypotenuse, sine. So this is a 3, 4, 5 triangle, isn't it? So here's the weight on the slope, and it's got 80 kilograms, so its weight, then I'll draw it vertically downwards, is 80g, mg. It's got a normal reaction here, so I'm going to try and draw it in as best I can. And we can label this R. So this is the line that acts through perpendicular to the slope. Okay, so find the normal reaction. Well, it's just staying on the slope, isn't it? Now, it's going to want to slide to slip, so the resistance force when it acts will be acting up the plane to hold it in place, and this will be mu r when it's on the point of slipping. So first of all then, let's have a look at part A. We're going to resolve the forces in this direction and apply F equals ma. F equals ma then in this direction gives, resolving the forces, there's no acceleration, so the forces are equal to 0 then, the resultant force. So we've got R minus, and it would be this force here, the component 80g cos of this, which is sine of this, which is cos of this. So 80g cosine alpha equals 0. Cos alpha is 4/5. So that tells us then that R is equal to 80g. Cosine alpha is 4/5. 5 goes into 80 16 times. 16 fours is 64. G, so that's the reaction force. 64g newtons is the normal reaction. The body is just about to slip. Find mu. So again, we can resolve the forces along this direction then. There's no acceleration, but it's just on the point of slipping. So apply F equals ma again then, along the line of greatest slope, and apply F equals ma, and that gives, there's no acceleration, so the resultant force is 0. So we've got mu r minus, now the force acting down due to the weight, mu r up, 80g cos of this, which is sine of this, 80g sine alpha. So that tells us that mu is equal to, mu r is equal to, move this over, 80g sine alpha, and we know sine alpha was 3/5, wasn't it? There it is there. So let's put it in straight away. And now I moved this over through the equals to flip the sign, and then the r we can move from times to divide once we've done that. And there's 64g underneath. So the g's cancel. 8's go into 64 8 times, and 8's go into 80 10 times. We've got an 8 here, so we've got 30 over 40. So it's 3/4. So mu is equal to 3/4 then, in coefficient of friction. Find the force that will move it up with an acceleration of 0.7. So let's go back to our original. Let's change the colour. Now this time, when it starts moving upwards, this will be mu r. We said it was 3/4, so let's put it in straight away. And there's a force here now, acting here. It's still going to have the weight, isn't it? So we know the acceleration though, don't we? So let's apply F equals ma up the slope now. So this is part C. Apply it up the slope, line of greatest slope. F equals ma then. gives, we've got the force that's pushing it up, pulling it upwards, F. We'll label it F because we don't know what it is. Label it F. Minus 3/4 R, wasn't it? Minus the force due to friction, 3/4 R, minus the component of weight, which is 80 G. Let's have a look at the component along the slope. It's 80 G cos of this, which is sine of this. 80 G times 3/5. 3/5, that component. F equals the mass, 80, times the acceleration, which we were told in the question, let's just go back and check, is 0.7. There. So there's our equation then. We know what R is. R is 64. That doesn't change. 64 G. So that tells us then F is equal to 3/4 times the 64 G. Move that over there. Plus 80 G times the 3/5 plus the 80 times 0.7, which is 56, which is already there. 80 times 7, 8 7s are 56, so it's 56. 4 goes into 64, 16. So this is 48G. Plus 5 goes into 18, 16 times 3 16s are 48 again. Plus 56. So it's 96G, isn't it? Plus 56. Tap it in the calculator then. 2 lots of 48G, let's put it in like that. Plus the 56 is equal to 996.8 newtons, and that's the force that's required to pull it up with an acceleration of 0.7.